Hi everyone, welcome back to my channel. So for today's video, we will discuss integration of rational functions of sine x and cosine x. So to integrate a rational function involving sine x, cosine x, or both sine x and cosine x, we shall use the substitution z is equal to tangent x over 2 or tangent 1 half x. This implies that cosine x equals 1 minus z squared over 1 plus z squared. Sine x is equal to 2z over 1 plus z squared and dx is equal to 2dz over 1 plus z squared. Okay, so how do we derive the three formulas? The three formulas, so we begin by using the identity for tangent double angle for tangent 2x. So for tangent 2x, we have the identity 2 tangent x over 1 minus tangent square x. But if we substitute 2x, let's substitute 2x to x. So therefore, we have tangent x is equal to, so divide the angle. So here the angle is 2x and then the right side is tangent x or 1/2 of the 2x. So we have 2 tangent x over 2 and then over 1 minus tangent square x over 2. So the value of x over 2 is z. So therefore, tangent x is equal to 2z over 1 minus tangent x over 2 squared. So 1 minus z squared. Okay, so from this, from the definition of tangent, so we have definition of tangent is if this is the x, so definition of tangent x is opposite over adjacent. So therefore, this will become 2z and then this will be the side 1 minus z squared. So if we use the Pythagorean theorem, so according to Pythagorean theorem, the square of the hypotenuse is equal to the sum of the squares of the other legs. So if we solve this part, the hypotenuse, this will become 1 plus z squared. Okay, and then from definition of cosine x and sine x, cosine x is equal to uh, cosine, so katowa, so adjacent over hypotenuse. So 1 minus z squared over 1 plus z squared, the hypotenuse. And then sine x, we have sine x is opposite over hypotenuse. So 2z over 1 plus z squared. And then for the dx, so we will solve for x in this equation. Z is equal to tangent x over 2. So to solve for x over 2, we have arctan. So to cancel the tangent, so the inverse of tangent is arctangent. Arctangent z is equal to x over 2. And then multiply both sides by 2. So therefore, x is equal to 2 arctangent z. And then get the derivative of this. So the derivative of that or differential dx is equal to 2 over 1 plus u squared. So we have z here. So we have z squared. Okay, and then differential, so we multiply it by dz. So let's put the dz in the numerator. So therefore, dx is equal to 2dz over 1 plus z squared. So therefore, we use this three equations. Cosine x, 1 minus z squared over 1 plus z squared. Sine x is 2z over 1 plus z squared. And then for dx, we have 2dz over 1 plus z squared, where z is equal to tangent x over 2. Okay, so try to solve these three examples. So we have three examples. Try to solve first before watching my solution. So evaluate the following integrals. Integral of dx over 5 plus 4 cosine x. Number 2, integral of dx over 2 minus sine x. And number 3, integral of dx over 1 plus sine x plus cosine x. Okay, so let's start with number 1. So number 1, integral of dx over 5 plus 4 cosine x. So let's use the substitution. So here are the substitution. Cosine x equals 1 minus z squared over 1 plus z squared. So we have cosine x here, and then for dx, so this is the identity, the substitution for dx. So we have 2dz over 1 plus z squared. And the value of z is equal to tangent x over 2. Okay, so let's use the substitution. So therefore, we now have this is equal to integral of the value of dx is 2dz 2dz over 1 plus z square all over 5 plus 4. And then let's substitute the value of cosine x. So this is the value of cosine x. So we have 1 minus z square over 1 plus z square. Okay, so let's simplify. So let's just distribute the 4 and to this. So therefore, we have integral of 2dz over 1 plus z square all over. So just distribute 4 to the numerator only. So we have 5 plus 4 times 1. We have 4. 4 times negative z squared. We have negative 4 z squared over 1 plus z squared. So simplify this part. So let's put over 1 in the 5 and then let's use the technique, the butterfly technique. So just cross multiply and then multiply the denominator. Okay, so therefore we have this now equal to integral of, just copy the numerator, 2dz over 1 plus z squared all over, so multiply 5 to 1 and z squared. So we have 5 plus 5 times z squared, 5 plus 5z squared. Then just copy 4 minus 4z squared because it is multiplied by 1. So we have plus 4 minus 4 z squared all over 1 plus z squared times 1. So it's still 1 plus z squared. So as you can see, we have both divide by 1 plus z squared. So shortcut, we just simply cancel this 1 plus z squared and then simplify the denominator. So therefore, we have 2dz over, so let's combine this, 5z squared minus 4z squared. So that is equal to z squared. And then 5 plus 4, that is equal to 9. So it is now in the form, integral of du over u squared plus a squared. So just move the constant 2 outside. So we have 2 integral of dz over z squared and then 9. Let's express 9 as 3 squared. So it's now in this form. So therefore, we have direct formula for this. We have 1 over a arctangent u over a and then plus c. So therefore, the final answer will be 2. And then we have 2 over 3, or because our a here is 3. So the u is z and then a is 3. So we have 2 times 1 over a. So 1 over 3. So we have 2 over 3. Arctangent z u over a. So u is z. So z over 3. Arctangent z over 3 plus c. So final answer, just substitute the value of z. The value of z is tangent x over 2. Okay, so therefore the final answer will be 2/3 arctangent z over 3, or that's the same as 1/3 z. So let's put 1/3 and then the value of z is tangent x over 2. So let's put in parentheses plus c. So this will be our final answer. 2/3 arctangent, 1/3 of tangent x over 2 plus c. Okay, so next number 2. Number 2, integral of dx over 2 minus sine x. Okay, so we use the substitution for dx, that is equal to 2dz over 1 plus z squared. And then for sine x, so we substitute 2z over 1 plus z squared. Okay, so therefore, the integral will be equal to dx is 2dz over 1 plus z squared. And then for the denominator, we have 2 minus the value of sine x is 2z over 1 plus z squared. Okay, so let's simplify the denominator. 2 minus 2z over 1 plus z squared. So let's put over 1 in the 2 and then apply the butterfly technique in addition of fraction. So just cross multiply and then multiply the denominator. Okay, so therefore we have this now equal to integral of 2dz over 1 plus z squared all over 2 times 1 plus z squared. So 2 times 1, so that is 2. And then 2 times z squared, so we have plus 2z squared. And then, so copy the sign minus 2z times 1, so that is 2z. All over 1 plus z squared. And then we can cancel this. So we both have 1 plus z squared in the denominator of our complex fraction. So therefore, we now have equals integral of 2dz over, so let's arrange this. So we have 2z squared minus 2z plus 2. So as you can see, we all have 2 for each term. And then in the numerator, we also have 2. So we can cancel out 2. So if we factor out 2 to this and then cancel in the numerator, so therefore we now have integral of dz over, so just divide 2. So we have z squared minus z plus 1. Okay, so now the denominator is quadratic, so therefore we will solve this by completing the square. So we complete the square of z squared minus z. What should be the last term to make it a perfect square trinomial? So to do that, so we just, the coefficient of z is 1. So we divide that by 2 and then we square it. So 1/2 square. So the missing part is 1/4 to make it a perfect square trinomial. So therefore, the 1 here, the positive 1, let's break 1 into 1/4 plus 3/4. Since 1/4 plus 3/4, that is equal to 1. And then we will regroup. So regroup. So regroup this. So it is it's now perfect square trinomial. So the square root of 1/4 is 1/2. So the sign of the middle term is negative. So therefore, it is now equal to integral of dz over, so we have z, so the minus, so minus the square root of 1/4, that is equal to 1/2 square. And then plus, express this, get the square root of 3/4. So square root of 3/4, 3 is not a perfect square. So we just write square root of 3 and then square root of 4, that is 2. So we have square root of 3 over 2 and then square. So when we square this, the answer is 3 over 4. So it is now in the form integral of du over u squared plus a squared. So the formula for that is 1 over a arctangent u over a plus c. Okay, so our u here is z minus 1/2. And then the differential du is equal to dz. Okay, so which is the numerator, dz. And then our a is equal to square root of 3 over 2. So let's just apply directly the formula. Or for this, we can simplify our u, z minus 1/2. So if we simplify this, so we put 1 in the z and then let's use this is the butterfly technique. So just cross multiply. So it's the same as z times 2, that is equal to 2z, 1 times negative 1. So negative 1 over 1 times 2, we have 2. Okay, so the value of u the same as 2z minus 1 over 2. So therefore, the answer will be 1 over a. 1 over a, the value of a is square root of 3 over 2. And then we have arctangent u over a. So we have 2z minus 1 over 2 all over a, which is square root of 3 over 2 plus c. So simplify. So we just cancel the 2. So cancel the 2. And then for this, so 1 over square root of 3 over 2. So the 2 will go up here. So the final answer will be 2 over square root of 3. And then arctangent. So 2z minus 1. So we have 1 over square root of 3. Or let's substitute the value of z. The value of z is equal to tangent x over 2. So therefore, we have 2 times tangent x over 2 and then minus 1 over square root of 3. Okay, so let's put that in parentheses plus c. So this will be the final answer. Or if you want to rationalize the denominator, you can rationalize the denominator. that this can be the final answer also. 2 over square root of 3 arctangent 2 tangent x over 2 minus 1 over square root of 3 plus c. Okay, so last number 3. So we have number 3, integral of dx over 1 plus sine x plus cosine x. So this time we both have sine x and cosine x. So for dx, we substitute this 2 dz over 1 plus z squared, and then for sine x, this is the value of sine x, and then for cosine x, so this is the value of cosine x. Okay, so therefore we have integral of dx, so we have 2 dz over 1 plus z squared all over 1 plus sine x. So we have 2z over 1 plus z squared, and then plus cosine x. So we have 1 minus z squared over 1 plus z squared. So we simplify this, or we both have 1 plus z squared as our denominator. So this one here can be expressed as, we can express the one here as 1 plus z squared over 1 plus z squared. Okay? Since our two fractions have 1 plus z squared as denominator. And then just combine the numerator. 1 plus z squared plus 2z plus 1 minus z squared. Okay? So that's the shortcut. So we have integral of 2 dz over 1 plus z squared. So let's just write all the numerators. So we have 1 plus z squared plus this, so plus 2z plus 1 minus z squared all over 1 plus z squared. So just cancel this 1 plus z squared, but in the numerator of the denominator of the numerator of the complex fraction and the denominator of the denominator, the complex fraction. So therefore, we have integral of 2 dz. So let's just simplify, combine like terms. So z squared minus z squared. So this can be canceled out. Z squared minus z squared. And then we have 2z and then 1 plus 1. So we have 2z plus 2. And then we can cancel out 2. Cancel all the 2's. So therefore, we have integral of dz over z plus 1. So which is now equal to ln of, our u here is z plus 1. The differential of z plus 1 is dz. So it's in the form du over u. Therefore, the answer will be ln of the denominator z plus 1. So ln z plus 1. So final answer, just substitute the value of z. ln of tangent x over 2 plus 1 plus c. So this is the final answer. Okay, so that's all. I hope you learned something from this video. Thank you for watching. And if you have math questions, so just comment your math question here or in my FB group, or just DM me in my messenger, RJ Enseñado. Please also follow follow me on YouTube. Follow me on Facebook, RJ Enseñado. Bye-bye and God bless.